For centuries, humans have gazed at the stars, wondering what to find in deep space and if other civilizations exist. After using telescopes, advanced technology allowed us to create space probes to better view our solar system and beyond. The Voyagers, two of the most famous spacecraft ever built, are still zipping through space. After 7 months of silence, Voyager 2 called Earth again. Prepare to learn more about these amazing spacecraft, the amazing things they found, where they are now, how far they have traveled from us, and their future. Humanity has launched only 5 spacecraft that have left our solar system. 2 of these spacecraft, the Voyagers, discovered more than expected and lasted longer than NASA predicted. We think they don't get enough love, so we'll tell you some interesting things about them, what they've discovered, and where they're going. The Voyager project, approved in 1972, was originally called Mariner/Jupiter-Saturn, and the probes were named Mariner 11 and Mariner 12. NASA changed the name because these 2 new probes had advanced beyond the Mariner spacecraft family. So, they were much more advanced. It's fascinating to examine these vintage probes' technology and hardware. The launch of these spacecraft 44 years ago is astounding. Voyager 2 on August 20, 1977, and 2 weeks later on September 5, 1977. Important advances were made in gravity-assisted orbital trajectories, which allows spacecraft to use the gravity of a nearby planet to boost their velocity, as long as they follow the planned orbit. The computers in both spacecraft are identical. In case of failure, each Voyager computer system had 2 copies. Each Voyager probe computer has 69.63 kilobytes of memory. That only fits an average JPEG photo file. Old digital 8-track tape machines store all the space probe's scientific data. They're not like your grandfather's 8-track stereo in his muscle car. There are no physical examples or museum pieces, but we have a photo. The data tape recorder for both Voyager spacecraft was subcontracted to Lockheed and manufactured by Odetics Corp. It could record at 115.2 and 7.2 kbps. Playback was slower at 57.6 kbps, with 33.6, 21.6, and 7.2 kbps options. The magnetic tape's composition and secrets for preventing degradation in space are unknown. Whatever those secrets were, they worked because both spacecraft's DTRs performed flawlessly from launch to grand tour to the extended mission that set both spacecraft on a course out of our solar system. Voyager's computers can execute 81,000 instructions per second. Your smartphone, where you're watching this video, is probably 7,500 times faster. They send 160 bits per second to Earth. For comparison, it would take 8.5 years to download a 5 GB Netflix movie using this connection. Voyagers have a golden phonograph record, which is probably the most intriguing thing about them. 2 gold-plated copper discs contain 115 analog encoded photos, 55 language greetings, a 12-minute Earth sounds montage, and 90 minutes of music. These were made in case an extraterrestrial civilization finds a probe. 3 plutonium dioxide radioisotope thermoelectric generators, RTGs, on booms power each spacecraft. Each probe had 11 scientific instruments, which would take over an hour to explain. Let's look at some of the exciting things the Voyager probes found and the images they captured with these instruments. Both spacecraft have different trajectories and speeds. At 61,155 miles per hour, Voyager 1 is moving faster, 7 kilometers per hour, compared to Voyager 2's 56,327.04 kilometers per hour, 35,000 miles per hour. Voyager 1 took stunning photos of Venus, Jupiter, Neptune, Saturn, and Uranus. Voyager 1 captured a stunning image of Jupiter's moon Io's erupting volcano. Observations of an active volcano outside the solar system were unprecedented. On February 14, 1990, Voyager 1 took the most famous image of the Earth, known as the pale blue dot, at 6 billion kilometers 3.7 billion miles away, and inspired Carl Sagan's book A Pale Blue Dot, A Vision of the Human Future in Space. On April 24, 1979, Voyager 2 began transmitting images of Jupiter that were used to create a time-lapse movie of the gas giant's atmospheric circulation, including the Great Red Spot Storm, which is 3 times the diameter of Earth. This was possible because Voyager 2 passed Jupiter and the Jovian moons closer. Voyager 2 passed Neptune's moon Triton on August 25, 1989. In this video of its thrilling encounter, Voyager 2 data showed Jupiter as we had never seen it before. Voyager 1 and 2 explored all of our outer solar system's giant planets, 48 moons, a unique system of rings, and magnetic fields. However, Voyager 1 and 2 would discover more, as you will see. They would encounter something more mysterious and unimaginable, something they weren't designed for. Voyager 1 was the first human-made object to enter interstellar space on August 25, 2012. The probe recorded a 1,000-fold drop in heliosphere particles and a 9% increase in galactic cosmic rays as Voyager 1 left the heliosphere, a giant bubble of charged particles that the Sun blows around itself. Since entering interstellar space, Voyager 1 has returned data on the universe's dark side. It was discovered that cosmic radiation is very intense and shows how charged particles from the Sun interact with particles from other stars to protect our solar system from deadly cosmic rays. On November 5, 2018, Voyager 2 became the second spacecraft to enter interstellar space after detecting a sudden decrease in solar wind particles from the Sun, an increase in galactic cosmic rays, and a stronger magnetic field. Engineers were amazed when Voyager 1 used its backup thrusters to orient itself so we could communicate with it on Earth in December 2017. The thrusters hadn't been used since Voyager 1's Saturn flyby in November 1980. How reliable! The Voyager probes constantly transmit. Each probe has a 22.4 watt radio transmitter, tiny refrigerator light bulb sized. The remarkable thing is that by the time the signal reaches us, the power has decreased to about 0.01 billionth of a watt. It's so small that NASA uses its Deep Space Network array of giant radio antennas at 3 facilities around the world: the Madrid Deep Space Communications Complex in Spain, the Canberra Deep Space Communications Complex in Australia, and the massive 70-meter, 230-foot, antenna at the Goldstone Deep Space Communications Complex in Barstow, California. NASA's global deep space tracking antennas are incredibly sensitive. These massive antennas must capture Voyager data from a weak signal with 10 exponent -16 watts, 1 part in 10 quadrillion. Modern electronic digital watches have 20 billion times the power of this pathetic watch. We're still talking to Voyagers. After a 7-month silence, mission operators sent Voyager 2 commands on October 29, 2020. The spacecraft flew alone while the Goldstone Deep Space Communications Complex's 70-meter antenna was repaired and upgraded. After all these years and while in interstellar space, Voyager 2 returned a signal confirming it had received the call and executed its new commands without any problems. Voyager 1 is 23.3 billion kilometers, 14.5 billion miles, from Earth, and Voyager 2 is 19.3 billion, 12 billion miles, as of January 2022. Most instruments on both probes have been turned off to conserve power. Voyager 1 will approach Ophiuchus in 40,272 AD and come within 1.7 light-years of AC plus 793888, an obscure Ursa Minor star. Voyager 2 will approach Ross 248 in Andromeda in 40,000 years, 1.7 light-years away. Unfortunately, and much sooner than this, we'll lose contact with both spacecraft, and they'll silently enter the interstellar void. An alien civilization finding a Voyager and powering it up in the distant future would be fascinating. If so, that primitive hardware may run again. Stay tuned to see if the Voyagers discover anything new and to keep up with the latest in our universe.